The floor of a modern metal fabrication plant is loud, heavy, and unforgiving. Moving thousands of tons of raw material at high speeds requires operating on the razor's edge of physical tolerance. Maintaining these systems requires a risk analyst and economic strategist. The modern industrial safety manager has evolved past the traditional image of a poster hanger. Today, they are highly analytical, data-driven decision makers. The difference between a facility running at peak efficiency and one paralyzed by a federal audit often comes down to a strict, standardized set of performance metrics. We are going to decode the exact mathematics the Occupational Safety and Health Administration uses to target its inspections. Specifically, we will look at the DART rate and see exactly how a slip on the plant floor is translated into a compounding economic loss. Managing industrial hazards is a rigorous engineering problem.
The facilities that survive treat safety as a core driver of their financial bottom line. Regulating millions of workplaces presents an immediate mathematical problem. How does a federal agency fairly compare the safety record of an automotive plant employing 2,000 people with a machine shop that employs 50? This formula solves the scaling issue. This is the incidence rate. You take the total number of recordable cases, multiply by a specific constant, and divide by the total hours worked by all employees. The constant at the center of this calculation is 200,000. That number is not arbitrary. It represents exactly 100 workers, clocking 40 hours a week, across 50 weeks a year. By locking that multiplier into the numerator, the equation forces every calculation to output a rate based on a theoretical 100-person facility. It scales the massive automotive plant down and scales the small machine shop up. To the regulator, every business is now mathematically identical in size. To populate that equation, the data has to come from a standardized source. This is the OSHA Form 300, the log of work-related injuries and illnesses. The critical data lives on the right side of this document. Columns H, I, and J force the safety manager to classify the outcome of every incident. Did it cause days away from work, a job transfer or restriction, or was it another type of recordable case? A manager cannot simply guess which column to mark. The entry is governed by strict legal definitions. Most importantly, the dividing line between basic first aid and medical treatment. For example, if a dock worker drops a pallet on his foot, gets a negative X-ray, receives whirlpool therapy, and goes back to work, that meets the definition of first aid. The incident is completely excluded from the log. But if a worker's finger is pulled into a belt pulley, resulting in a tiny fracture and the application of a splint, the threshold is crossed. A positive X-ray dictates mandatory recording, landing a checkmark in column J. Moving down the log to file 5, we see a dock worker who sprained an ankle and was moved to a temporary office job. This triggers column I, classified as restricted work activity. This presents a severe regulatory trap for management. Even though the employee is physically present, on the clock, and being productive, if they cannot perform their normal routine duties, the system counts it identically to a lost workday. A high incidence rate doesn't happen by accident. It is meticulously built, case by case, through the strict binary legal definitions applied on this form. The log also forces a separation between the two major categories of workplace risk: acute safety hazards, like a falling beam, and chronic health hazards, like prolonged noise exposure. Injuries are immediate and obvious. Illnesses are much harder to track. Diagnoses are frequently delayed, and symptoms often mimic conditions caused by off-the-job activities.
Still, OSHA requires facilities to formally categorize these distinct threat types on the compliance log under column M. Look at File 12. A worker on the final assembly line is diagnosed with carpal tunnel syndrome from repetitive motion. This is officially checked as a recordable illness. Because chronic conditions evolve, maintaining the log is an ongoing process. If an illness logged today results in surgery and weeks of recovery later in the year, the safety manager must retroactively update the form to reflect the new lost time. OSHA mandates this tracking to force investigations into slow, systemic deterioration. It requires management to balance ergonomic workstation redesign with immediate mechanical repairs. Once the calendar year closes, the raw data from Form 300 is aggregated into the specific acronyms that federal regulators and insurance companies use to grade a facility's performance. The broadest metric is TRC, or Total Recordable Cases.
This is the absolute sum of all qualifying incidents, funneling columns H, I, and J into a single number. For years, OSHA relied on a narrower metric to select high-hazard industries for priority inspections, the Lost Workday Cases Incidence Rate, or LWDI. This metric deliberately excluded illnesses, pulling only from lost-time injury cases. Modern enforcement has shifted to the DART rate, days away, restricted, or transferred. This shift was intentional. DART explicitly pulls in chronic illnesses and restricted work activity. This closed a loophole where facilities could temporarily hide severe hazards by immediately moving injured workers to light desk duty. Some states and enforcement agencies apply an even stricter filter, DAS-WE, or days away from work injury and illness. This metric isolates the most severe incidents, pulling exclusively from column H and rejecting restricted duty transfers entirely.
When analyzing DART and DAR-WE, there is a critical mathematical distinction that is frequently misunderstood by operating personnel. These specific metrics count the number of cases that resulted in lost time. They do not add up the cumulative total of individual days lost to those injuries. These data flows require absolute precision because they act as numerical tripwires. A sufficiently high TRC, or DART rate, compared to the national average is exactly what drops a facility onto OSHA's priority inspection target list. The mathematical reality of regulatory compliance maps directly onto the financial reality of running an industrial business. Every recorded incident represents extracted capital. An elevated DART rate triggers immediate financial penalties, appearing as skyrocketing workers' comp premiums and direct medical payouts. To an operations director, those are just the tip of the iceberg. The actual damage lies below. Hidden costs accrue instantly. Production halts, coworkers lose time managing the emergency, and supervisors abandon schedules for investigations. Long-tail costs compound for weeks: equipment repairs, premium overtime to catch up, and funding the learning curve of a replacement worker. Confronted with these costs, untrained managers often demand the total elimination of all workplace risk. This is the zero hazard fallacy. In heavy industry, eliminating all risk is physically impossible, and attempting to do so is economically ruinous. The actual goal of safety management is precise capital allocation. It requires using incidence rate data and thorough cause analysis to execute the calculated, targeted elimination of strictly the unreasonable hazards. Precise record-keeping acts as the central diagnostic tool for identifying systemic inefficiencies. It protects the bottom line by exposing hidden operational costs that basic compliance alone would miss.